All right. Hey guys. Hey guys. Good morning. Yeah, so today we'll be revising. Today we'll be revising core topics starting with computer networks and then we'll move to HTML, CSS and remaining topics basically. I'll just check if I'm live or not. Cool, I'm live. That being said, let's move on. Computer networks. Just 12 questions, but too much answers. Yeah, so computer networks. The first question is what is the difference between private IP and public IP? So, a private IP is used within a local area network to identify devices internally. These IPs are not routable on the internet and are reserved for internal communication. Example are ranges like 192.168, 10. And so on. A public IP address is globally unique and assigned by ISP. It allows devices to communicate directly over the internet. Public IPs are routable, meaning packets with these addresses can travel across different networks worldwide. This means if I have my mobile, then and if I connect my laptop to my mobile's hotspot, since both of them are using the same internet, if I go to this website, I think find my IP, it will show the same result. But if I go to my settings and then I check my IP, that would be different. This is the difference between public and private IP. So when I connect my laptop to Wi-Fi at home, my laptop is assigned a private IP by the router. However, when I access Google, the request goes out using my ISP. Google server sees this public IP, not the private ones. So this ISP is basically given by services like Jio and Airtel. They give us public IP. These are typically managed by network translation and Google sees not the private. This is typically managed through network address translation on the router, which maps internal private IPs to internal private IPs to public IPs for internet access. Question 1. Why do we need private IP addresses? Public IP exist? Because IPv4 addresses are limited. If every device required a public IP, we would have exhausted them much earlier. Private IPs allow multiple devices to share a single IP via network address translation, which conserves address space. Can two devices in different private networks have same IP? Yes. For example, my laptop at home and a server in a company LAN can have both 192.168 as private IP. Since private IPs are present internally, they don't conflict globally, but within the same LAN, IPs must be unique. How does NAT come into play here? NAT is used on routers to map private IPs to routers' public IP when accessing the internet. If three devices inside the home all open Google, NAT rewrites the request to use a single IP. The router keeps a mapping table so the responses are sent back to the device. What about IPv6? Do you still need private versus public? Address space is so large, theoretically every device can have unique public IP, but I would think still exists for internal communication and security reasons. What happens when you type www.google.com in browser and press enter? So you know what guys, I am a bit sad on the fact that I'm not getting any job. Second thing, I'm not affected by the thing that I'm not getting a job, which I feel is another sad thing because think I should react to this situation, but people can have varied opinions on this. They can say, it's good to be neutral in situations like this. But man, it's not great, I think so. I'll just show you a couple of things to do. Honestly, man, regardless, I should not overthink. So what happens when you type google.com in your browser interface center? So below are the steps that are being followed. The browser checks if the content for google.com is already cached locally and still valid based on HTTP cache headers. If yes, it loads directly without going to the network. Next is DNS lookup, browser and OS cache first. Browser checks its own DNS cache. If not found, it asks the OS. OS may have it cached too. If still not found, the OS requests the configure DNS resolver. Usually ISP is like ISP, Airtel, Jio. DNS query is typically sent via UDP port 53. If the response is too large, TCP may be used. Resolver checks step by step. So root.com, then we have TLD, Google's authoritative DNS, and finally returns the IP. So we have this resolver and we have like three different kind of servers. So first one checks which domain it is referring to .com. Then TLD refers to which server it might be present. It has a mapping, and third one it goes to that server. 3CP connection setup. Browser initiates TCP connection with a resolved IP on the port 443. TCP uses the three-way handshake. Client will send syncing, server will send syncing plus acknowledgement, client will send acknowledgement. Then TLS handshake. Since Google uses HTTPS, after TCP handshake, a TLS/SSL handshake happens. Client and server agree on encryption algorithms. Server sends its SSL certificate issued by a trusted CA. Certificate authorizes something. Client verifies the certificate validity. A session key is exchanged, and now a secure encrypted channel is established. The browser sends an HTTP request to Google. Get Google load balancer and web servers receive the request. A reverse proxy like Google content routes it to appropriate backend. The server fetches the data. HTTP response is sent back. Browser checks cache headers and decide if it is to store the response or not. The passes HTML download the referenced resources often in parallel. It might have different they use the same rendering process. JS execution 23 connection ending. If connection kept alive is set, this may be used. So in short, what happens is first browser will check its cache. If not, then browser will check its own DNS cache. If not, OS will just check in its cache as well. If it's not present, it will set up a TCP connection to the server. If it is not present, then OS requests your DNS resolver. OS requests the configured DNS resolver. Then it sets up then TCP connection happens, three-way client. TLS handshake, I mean, they decide on how to send the data between each other. Then HTTP response is sent from the client side, server processes it and sends the response. So it's something like this. You are typing google.com. So what is happening? It is checking in browser cache, not there, checking in OS cache, not there. Then it is hitting the authorized DNS resolver. Like, Airtel RJ, it will request that to, bound this URL. What this will do is, I mean, Airtel Jio will redirect and it will find where it is. Now what happens is from client side, you will send a request, like you'll do basically three handshakes. So client will send sync flag, the server will receive and acknowledge, so it will send sync plus async, sync plus acknowledge, and client will then acknowledge. This way, three-way handshake is done. Now what happens is connection is established, but how are they going to send messages securely? So for that, basically a TLS handshake happens. Google uses HTTPS. So client and server agree on some encryption algorithm. Server will send a SSL certificate uh, issued by a trusted CA. Server will send a SSL certificate. Client will verify the certificate validity, and a session key is exchanged basically between both of them. Now this way connection is established and secured. Now client will send the HTTP request. Server will receive that. It will just check it in its servers using load balancer and all, and it will send a response, HTTP response. Now browser will receive that response and it will check if it should store the response or not based on the cache address from the response. Now once the response is received, a client side starts the rendering process. That is, it builds the page, HTML, CSS, JS, and all. Now, yeah, so this is what happens more or less. Why does DNS use UDP? Mostly not TCP, because DNS queries are small. UDP is fast and less worried. What if DNS fails? The browser cannot resolve the hostname, then I can use it like this. Okay. Next question is, does DNS contain all records of IP addresses? If no, why? So no, the DNS does not contain the record of every IP addresses in the world. Instead, it's distributed hierarchical system. The entire DNS database is spread across millions of DNS servers globally, each responsible for specific domains. If DNS tried to maintain a central record of all IP addresses, it would be impossible to manage due to sheer scale and constant updates. Instead, DNS works like a directory. Root servers knows where top level domains are present. TLD servers knows which authoritative servers handle specific domains. Authoritative server contains the actual IP record for that domain. So, if possible, just generate a diagram for these as well with the help of ChatGPT. ChatGPT.com. Generate a diagram of the above. Okay, in the meantime, we'll just see this. So if I type bitmsword.ac.in in the browser, my system resolver will first check its local DNS cache, the query DNS servers, then query DNS servers up the hierarchy. Eventually, it reaches the authoritative DNS server for ac.in, which gives the IP of bitmsword server. The IP is then cached locally for faster future lookups. What is DNS? Is that an internet naming system that translates human readable domain names like into IP addresses required by computers to communicate. Why not keep one big central DNS database? Because internet has billions of devices and domains. Centralized system would be a single point of failure, very slow and impossible to update in real time. The distributed model ensures scalability, reliability, and redundancy. How does DNS handle scalability? One way is by caching. And next is wire distribution. Each domain is managed by its own authoritative server. What if DNS server fails? DNS is multiple redundant servers, for example, root servers are replicated across the world by any cache. Similarly, authoritative DNS providers like Cloudflare, Google, AWS deploy globally distributed. Can DNS records be updated in real time? Yes, but updates depend on TTL, time to live. If a record's TTL is set to 24 hours, cache resolver won't see the change until that expires. That's why sometimes when companies migrate website DNS propagation technology, can DNS record be updated in real time? Let's see the change. Oh, I forgot one thing. I forgot this to post this on Twitter. Yeah, videos. It's like 867 posts on Twitter so far. Yeah, so you can see from this diagram about what happens when we type if DNS does not contain record the whole IP address. I'm asking that who sets this TTL? TTL value. The domain number sets the TTL. No authoritative servers have all IP addresses. No. Even authoritative DNS servers do not have all IP addresses. It only stores records for the domain it is responsible for. Explain OSI model in detail. The OSI model is a conceptual framework that standardizes how data travels across the network, each using specific response. Okay. First one is application layer. It provides network services directly to end user application. Next is protocol. When I type google.com, the browser is HTTP at the application layer to the console page. Presentation layer. I'll just see both question. TCP versus UDP, switching routing. IP roadmap. I'm just searching the question, about VPN and all. Let's complete this because it's actually interesting, I believe. So, yep, I'll complete it. So, it's a conceptual framework that standardizes how data travels across the network. It's divided into 7 layers. So, first is the application layer that provides network services directly to end user application. For example, when I type google.com, the browser uses HTTPS with the application layer to request the web page. Next is presentation layer. It is responsible for data translation, encryption, and compression so that different systems can understand each other. Protocols SSL/TLS, JPEG, MPEG, वगैरह वगैरह. Real world example: when I connect to Gmail over HTTPS, my data is encrypted/decrypted using TLS at the presentation layer before reaching the application. Here next is session layer. It manages and controls session, establishment, maintenance, and termination between applications. Where protocols like NetBIOS are used. So, for example, in a video call, the session layer keeps track of active sessions so both sides stay synchronous with the call needs. The transport layer, it was for encryption, compression, and translation. Transport layer is for end-to-end delivery between end-to-end delivery and error recovery. Protocols are TCP and UDP. Downloading a file from Google Drive, TCP ensures reliability and retransmits lost packets. UDP is used since speed is prioritized. Cool. I'm connected back to my host the Wi-Fi. Network layer handles logical addressing, routing, and forwarding packets across network. Protocols are IPv4 and IPv6. So when I send a request to Microsoft.com, the data is routed using the IP address. handles logical addressing, routing and forwarding packets across networks. Protocols are IP4. When I send a request, the data is routed using IP address of microtransfer. Router use BGP to determine best path. The data is routed using the IP address. Again, I'm not clear on the what should I say example, so I'll just rewrite the example. Data link layer provides MAC addressing error detection, frame delivery between two. So here it's frame avoids packets. When I connect my laptop to Wi-Fi, the access point identifies my device using its MAC address and ensures link display. Send using the IP address. Understood this. Physical layer is dealt with actual transmission of raw bits of physical mediums. Network and Ethernet will use. Physical layer is transmitting optical signals that carry bits of my request to the server. So example where multiple layers interact. So when I watch a YouTube video, uses HTTPS to request the video. Presentation layer compress video compressed from MPG. Session layer keeps the streaming session live. TCP ensures reliable delivery of chunks. Network layer uses IP to route packets. Data link layer Wi-Fi frames delivered via MAC addresses. Physical address bits sent as radio waves to my router. Explain these protocols. HTTP. Sure. So HTTP is an application layer protocol used for communication between browser and server, client and server. It's stateless, meaning each request response is independent. It defines method like get, push, put, delete for resource access. Now HTTPS is simply running over an encrypted channel using SSL/TLS. This ensures confidentiality, integrity, and authentication. Without HTTPS, data like login credentials or payment information would travel in plain text. Real world usage example. When I log into it, so while going through this example, now I'm checking my emails. If there is anything new. Alright, man. I'm gonna continue, but I'm browsing my LinkedIn right now. I'm interested to work in a US based company, I hope I achieve that someday. Next is SSL by TLS. TLS are cryptographic protocols that secure communication over a network. TLS works between the transport and application layers. It's asymmetric encryption, public key for handshake and authentication. Then it switches to symmetric encryption for actual data transfer. When I visit Amazon.in, the browser performs a TLS initial browser access certificate issued by a certificate authority. The routing protocol is a path between different organizations within one. Just time. Today is my dad's birthday, by the way. So yeah, shout out to my dad. Explain TCP versus UDP. Establishes the connection through handshake before sending data. Guarantees delivery using acknowledgement, retransmission, and sequencing. Packets arrive in same order they were sent. It is slower but reliable because of error chicken and handshakes. We use different kinds of protocols for different use cases. For UDP connection layers, no just send packet, no guarantee of delivery, less storage, real-time applications, and speed management. When one is on call, UDP is okay. Retransmission cause delay, but it's kept. Switching. A switch connects devices within the same network or LAN. Works with MAC addresses to forward frames. Creates a MAC level and switch port is connected to which device doesn't care about IP address. Connects 20 pieces. In my office, LAN switch connects 20 pieces. If PC1 doesn't data PC2, the switch looks at the MAC address port directly. A router connects different networks. Switch is present inside router, by the way. These are two versions of internet that internet protocol is set up for routing data. Both are written on MAC addressing and IP addressing of switch router. So MAC address and IP address are both identified for devices on a network but serve different purposes. MAC address is a unique hardware identifier. Note: we have more than one MAC addresses used for local network communication, while IP are for routing data across network. MAC address. A MAC address is unique identifier assigned to a network for communication within a local address. Typically written, used to add the data link layer to ensure data packet reaches the correct device on the local network. An IP address is a logical address used to identify a device on a larger network like the internet. Let's understand it with the help of scenario so that anyone can understand. Laptop connects to a phone's Wi-Fi. Your laptop's Wi-Fi card has a MAC address. A phone's Wi-Fi card has a MAC address. Inside the hotspot, like a mini router, the connection with laptop to phone uses MAC addresses to identify which device on Wi-Fi should get the packet. Example, when a laptop is Wi-Fi, it says this to phone's MAC address on laptop. That's local delivery with a network. A phone gives a laptop an IP address or a DHCP. What the hell is DHCP? What is DHCP? DHCP. It is a network protocol that automates the assignment of IP addresses. So phone assigns laptop IP, private, phone IP, gateway. The laptop is now identified as this. I'm a bit doubtful. Open google.com, laptop request 84911 user strips matter to the backup partition on mobile data set explanation for the IP provided by the telecom operator. Google only sees voice. Assigns laptop operator set the phone as default gateway on the local Wi-Fi back is that private. What is the difference between hub, switch, and router? A hub is a more specified, it operates at physical level, doesn't understand addresses, it simply repeats incoming signals to all connected devices. This causes collision and makes network efficient. Its switch works at data link layer, it understands MAC addresses. When a packet comes in, the switch checks the MAC address table and forwards it to only specific port devices. Broadcasting it to all. Instead of broadcasting call, this reduces collision. A router works on network layer, it understands the IP and is responsible for connecting different networks. A router decides best paths for packets to travel across networks. Okay. Let's say we have an offer. If we connect 4 pieces with a hub, PG1 send it to. If we represent hub with the switch, the switch looking for and okay, router case. Now suppose the officer and its access internet, the switch can't appear because it works on the internet. A router with a public IP connects this LAN to ISP's network, performs NAT, network address translation. Now explain subnetting. It's the process of dividing large network into smaller, more manageable subnetworks. This is achieved by using a subnet mask, which is a set of bits that identify which part of an IP address represents the network and which part represents the host. It helps in improving the network performance, security, organization by creating smaller broadcast domains and allowing for more efficient use of IP address. What is a firewall? It is a network security system that monitors and controls incoming and outgoing network traffic based on predefined rules. Its main purpose is to act as a barrier between trusted internal network and an untrusted external network, like the internet. Firewall is a network security system that monitors and controls. Better to draw a diagram. The monitoring controls its main purpose. Okay. So I'm generating a diagram for this currently. Now explain about VPN, how it works. It creates a secure and encrypted tunnel between your device and a remote VPN server. It hides their IP address, encryption and traffic. It is private. The VPN server then forwards the encryption. The client encrypts all outgoing traffic, encrypted takes into account. So more or less you can refer this diagram. That being said, I'll just save this and upload from GitHub as well. I'm updating on my GitHub, so that anyone who is referring can get my PDF from here. Next, we'll be covering HTML. Yeah, man, that's it. Now I'll just export the video. Alright, this is done. Now I have to upload it on my GitHub. Upload files, source file, Obsidian. This is right now. RCN. Commit changes. Alright, so we'll just see HTML. What is Doctor? It tells the browser how to enter the page. File. What is the purpose of language? It specifies the language of document as English, reading, screen read, auto open data. They define how your content appears when shared on social media, enhancing visibility. What's the property difference between meta property and meta name? Property is used for applying graph tags for social platform, while name is used for time. And it's not really required, but okay, that being said, we have done HTML. Oops is done as well. Now we'll cover operating systems, but not in this stream, maybe some other time. So yeah guys, I'll leave you right now and come back later.